Welcome back to the last problem. One thing you can't do, there is no greatest common factor. That one's a definite no. You also can't use substitution. You don't have three terms where the exponents are doubles. That's leaving factor by grouping and division. The best would be choice would be factor by grouping, because you know, if we look at here, you see some things in common, right? We've got things divisible, you know, by fives, and that looks kind of promising. That maybe x cubed and 20x squared, maybe that has something in common with 25x and 500, right? At least the 20 and the 500 are both divisible by 10 and 5, so that looks kind of promising. This would be okay. You could use division and find your answer, but I think we can do it a little faster with factor by grouping, and it's worth a try. If we're wrong, we'll figure it out like in 2 steps. All right, so x cubed plus 20x squared are a group, plus negative 25x minus 500 are a group. Okay, and we'll pull out our greatest common factor, which is an x squared. Right, and then we would have x plus 20, x plus 20, and then our greatest common factor here, both divisible by negative 25. And we would have x plus, right, well, 25 goes into 50 twice, so it's going to go into 500 20 times. We have x squared minus 25 times x plus 20 equals 0. And then we can factor here. We have x minus 5, x plus 5, difference of squares. Here, not so much. So let's solve these guys, and then let's take care of the x plus 20. So x minus 5 equals 0. X is 5 is one solution. There we go. X plus 5 equals 0. X equals negative 5 is our second solution. We have to use square roots for the rest of this. So, oops. Oh, no, we don't. What am I saying? What am I saying? Silly me. This isn't an x squared plus 20. It's just an x plus 20. Silly bee. Our last solution, x plus 20 equals 0. X is negative 20. And there we go. Look how simple. Easy, squeezy, lemon cheesy. Look at that. We did it in 3 minutes. All right. That was my last problem, but I want to do one other thing. With this one here, I'd really hope you'd try substitution, because this is going to be a lot longer problem if you use division. This one over here will be longer, the other one that was division, but not as bad. And that was, where'd he go? Oh, did I just go right past him? Oh, no, I didn't. It's this, oh, there he is. This part here, the x to the 4th minus 7x squared plus 12. Wouldn't have been as bad, but you only have 2 possible choices. If you're using the rational root test, you would have, so once you were down to the x to the 4th minus 7x squared plus 12, you would have actually all the factors of 12 as possibles. So that would be 1, 2, 3, 4, 6, and 12. All right, so that's going to give you 12 choices, right? 12 possibles, those factors of 12. All right, and we see that only 2 of them were actually going to be solutions, 2 and negative 2. All right, so let's solve this one using the rational root test. I'll try and go real quickly, right? Because we already know what one of the solutions is going to be. Actually, we know what all the solutions are going to be, but we'll use one of them. So there'll be no trial and error over here. All right, and let me erase the ink. Oops, come on. Come on. Any day now. Don't make me regret this choice. You know, I'm going to go away from the board. I'm going to come right over here, and I'm going to clear the ink. There we go. Much faster. All right, so if we're solving what was left, which was x to the 4th minus 7x squared plus 24, according to the rational root test, our possible solutions would be plus or minus, oops, no, one of these is incorrect. Come on. There we go. So we'd have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And if we divide those by 1, we'd still have the exact same values. So we already know that 2, for instance, was a solution. So let's just say we guessed 2. All right, when we write this out here, just to kind of review, what if you don't, feel real comfortable with substitution yet, or what if you don't realize it? All right, so my x to the 4th is 1. Remember, you don't have an x cubed, so you have to represent him with a 0. You've got an x squared. You don't have an x, but you've got a constant. So for synthetic division, you'd have 1, 0, negative 7, 0, 12. And then you'd bring down the 1. 1 times 2 is 2. Add, you'd get 2. 2 times 2 is 4. Add, you'd have negative 3. Negative 3 times times 2 is negative 6. Add, you have negative 6. And negative 6 times 2 is negative 12. Add, you get 0. Right? And so then you'd have this x squared plus 2x, x cubed. X cubed plus 2x squared minus 3x minus 6, and we set that equal to 0. And now at this point, you could use factor by grouping and not have to use synthetic division twice. Not that it was that hard, but if you didn't really know what the answers were, that might take you a little longer. It's a lot easier when we know what the answers are. So x to the x cubed plus 2x squared would be a group, plus negative 3x minus 6 would be a group. And then we'd pull out the x squared, and we'd have an x plus 3. And then we pull out the negative 3, and we have an x plus, wait, how did that become a 3? We have an x plus 2. And we pull out the negative 3, and negative 3x divided by 3 is x. Negative 6 divided by 3 is 2. And then we have x squared minus 3 times x plus 2. And you remember from the other page that, or from earlier I should say, that you have x equals negative 2, and you take the square roots. X squared minus 3 equals 0, and that would just be x squared equals 3. And you take the square root of both sides, and you wouldn't forget the plus or minus, and you'd probably write all over your number 3. And you'd have x equals plus or minus the square root of 3. All right, so you'd get the same solutions. It was a little less work probably to use substitution, particularly if you don't pick the right answer right off the bat, but it's not too bad. I think that other one, because it has so many more factors, would have taken you a while to solve. And that is the end of this podcast, now that I've written in the answers correctly. All right, so hopefully this was a good review for you, and this is the end. So goodbye.